Ever wondered what actually happens the moment you hit the power button on a Linux machine? It is not magic, it's a precise sequence of events happening in milliseconds. Let's break it down. The very first thing that wakes up is either the BIOS or UEFI. Think of these as the bodyguards of your hardware. Before Linux even gets a chance to load, these programs run first and make sure everything is connected and responding, like your keyboard, display, storage, drives, all of it. UEFI is the modern version. It boots faster, supports larger drives, and has security features like secure boot that BIOS simply doesn't have. To differentiate, here is one major difference between them. BIOS works with something called the master boot recorder, which caps your disk size at 2 terabytes. UEFI ditches the limitation completely by using GPT or GUID partition table, which supports the drives of virtually unlimited size. If you're running a modern system, you're almost certainly on UEFI with GPT. Before anything else loads, the BIOS and UEFI run a quick self-check called POST, which stands for Power on Self-Test. It's basically your computer asking itself, is everything working? Checking the RAM, CPU, storage, and connected devices. If something fails post, you will see an error on screen before Linux ever starts. Once post passes, the system needs to find your bootloader. By default, it checks your hard drive first, then USB, then optical drives. You can change this order in BIOS or UEFI setting, which is useful if you're installing Linux from a USB. On a BIOS system, the bootloader lives in the very first sector of the hard drive, which is called the master boot recorder. On UEFI system, there is a dedicated EFI partition that stores the bootloader files. The bootloader has 3 jobs: find the Linux kernel on disk, load it into memory, and hand control over to it. The most used bootloader on Linux today is GRUB. You've probably seen it. It's menu that appears asking you which operating system to boot if you have more than one installed. GRUB supports multiple operating systems. It has a clean graphical menu and gives power users serious customization options. Its older processor Lilo still exists, but you will almost never see it on a modern system. Once GRUB does its job, it loads the Linux kernel into memory and steps aside. Now the kernel takes over. First thing it does is decompress itself into memory. Then it scans the hardware and loads the device drivers it needs to communicate with everything. Your GPU, network card, USB controller, all of it. After the kernel is settled, it launches the very first process. And on modern Linux systems, the process is systemd. Systemd is the parent of every other process on your system. Everything that runs on your Linux machine traces back to systemd. It handles a lot: loading remaining drivers, mounting your file systems, starting background services like networking and audio, managing your login screen, and finally launching your desktop environment. Systemd uses something called targets to decide what mode to boot into, whether that's a basic text-only environment or the full graphical desktop most of us use every day. These targets are the modern replacement for the old run-level systems, if you have ever come across that term before. And that's the full Linux boot process, from the moment you press power to the moment your desktop appears. Every step in the chain has to succeed for Linux to start correctly. By now, when something goes wrong at boot, you will actually know which stage failed and why. If this helped you understand Linux better, subscribe to Max Ops. We break down how systems actually work under the hood, from Linux internals to DevOps and cloud engineering. More videos dropping.